Hello Big Reds, this is Mr. Fishel talking again. This is exam review video part 2. Make sure you watch part 1 before you watch part 2. Again, these are not the exact exam questions, but they are similar to questions that are going to be on the exam, so you really need to focus and take notes on these problems that we're going to do. Okay. Alright, this type of problem right here, first of all, we know that all the angles in triangle add up to 180 degrees, so you could take, this box means 90 of course. So you could take 90 plus 65 plus x equals 180. Always do that with angles of any triangle. You can subtract 90 from these and you get 65 plus x equals 90. Then subtract 65 from each side here. You get x equals 25 degrees. We know that this type of triangle must be an isosceles triangle because, as you can see with the 16s, those are the lengths of these sides, so this is congruent to this side. That means the base angles must be congruent as well. So if I know that these two angles are the same, I can make this an x and make this an x. And I know that angles of a triangle add up to 180 degrees, right? So I could take 2x plus 50 equals 180. Once I subtract that 50, I'm left with 2x's equals 130, and I divide by 2 and get x equals 65 degrees. So both these angles must be the same. In this case, they're going to be 65 degrees. Oh, this is a good one right here. You need to know your angles. Very, very, very important, your angle pairs. There will be quite a few questions on the exam about your angle pairs. So, again, let's just refresh the names of the different angle pairs. We have alternate exterior angles. We have alternate interior angles. We have corresponding angles. We have consecutive interior angles. Vertical angles. And a linear pair. I'm going to give you some samples of these types of angles. First of all, alternate exterior angles. Alternate exterior would mean it's on the outside of these two parallel lines. So again, outside of my ruler here. So an example of alternate exterior angles would be like angle 1 and angle 7. These two are alternate exterior angles, or another example might be angle 2 and angle 8. Angle 2 and angle 8 are alternate exterior as well. Alternate interior now, a little different. They're on the inside, inside of these two parallel lines. So they're in alternate spots, so it would be like angle 4 and angle 6, or angle 3 and angle 5. Corresponding would be in the same position. For instance, if I had 1, if you look at this group of 4 angles and this group of 4 angles, the angles that are in the same position, for instance, 1 is top left, 5 is top left. So 1 and 5 would be corresponding. Also, 2 and 6, and 4 and 8, those are both bottom left. Or angles 3 and 7. They're both bottom right of these group of 4 angles. So if they're in the same position, they're corresponding angles. Consecutive interior angles. These angles right here are inside parallel lines, but there are no transversals or lines between them. So for instance, 6 and 3 are consecutive interior angles, or 4 and 5 are consecutive interior angles. Okay. Linear pair, vertical angles are next. Vertical angles are across from each other where lines intersect. So like 1 and 3 and 2 and 4. So 1 and 3, or angles 2 and 4. Okay, and then linear pair would be next to each other. I think of them like a pair of shoes. 1 and 2, or maybe 1 and 4, or 3 and 4, or 2 and 3. See, they're next to each other. Okay, so these angles, these vertical angles are always congruent. Linear pair are always supplementary, which means they add up to 180 degrees. Okay. These angles have special properties when the lines are parallel. So if these lines are parallel, and they must be parallel for these properties to happen, alternate exterior angles are congruent. Alternate interior angles are congruent. Corresponding angles are supplementary. That means they add up to 180. And consecutive interior angles are congruent. Next. Okay, so again, let's assume that these lines are parallel. They look parallel, but we're going to assume that they're parallel. That's what these triangles mean, they're parallel. Then I can fill in the rest of these angles. So if this is 105 degrees, corresponding angles tell me this is 105 degrees as well. These are alternate exterior angles, so these are 105 degrees. And then these are alternate interior angles, so these are 105 degrees. The other angles, these are a linear pair, so these add up to 180 degrees. Take 180 minus 105 gives us 75 degrees. This is 75. These are 75 as well. You'll notice that all of the 8 of these angles, if these lines are parallel, are either congruent or they're supplementary. One way you could look at it is you could see these angles are obtuse angles, and these angles, the 75s, are all acute angles. One way you could look at it. So, all right. I'm going to skip some of these. Oh, why not? We'll do one of these. How about this? All right. So, in this case, we have x and 5x plus 6 degrees. Now, these are a linear pair. That means they add up to 180. To solve this, I could take x plus 5x plus 6 equals 180. Add these together, and I get 6x plus 6 equals 180. Subtract 6 from each side. 6x equals 174. And divide by 6. X equals, let's see, I think 29. So you use properties of angles like we were just talking about to solve for missing variables like this. All right. And then if you plug this back in, x is 29 degrees. 5 times 29 plus 6, that's going to equal 151 degrees. And these two do add up to 180 degrees. Okay, distance. Oh, this is a good, back from unit 1. All right, find the distance. You could do a couple different things. If I'm looking at A, let's say this is the point 0, 0. Okay, so A is the point 2, 2. And B is the point, let's see, 2, 3, 4, 5, 6, 7. And up 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is 0.79. So you could do this a couple different ways. One way you could do it is Pythagorean theorem. You could make yourself a right triangle. And you could look at the spaces. You could see your 5 spaces here, 1, 2, 3, 4, 5. And from here, there are 7 spaces, 1, 2, 3, 4, 5, 6, 7. So you could take 5 squared plus 7 squared equals c squared, or 25 plus 49 equals c squared. Add these together, get 74 equals c squared. Take square root, and square root of 74 is about, c is about 8.6. That's one way to do it. Another way to do it, if you're looking at your head, is you could say distance equals square root of the difference of the x's. So I could take 7 minus 2, get 5 squared. And the y's go from 2 to 9, which is 7 squared. When you do that, you get 25 plus 49, d equals square root of 74, and you get the same answer that way. So a couple different ways to do it. All right. Write the equation through the point C parallel to AB. Oh boy, and it looks like point C is way over here. So now, first of all, we have to get the coordinates of point C. So the coordinates of point C are 1, 2, 3, 4, 5, 6, 7. 1. So 7, 1. Coordinates of point A are 2, 2. Coordinates of B are, looks like 7, 2, 3, 4, 5, 6, 7, 8, 9. 7, 9. We're going to continue this part on part review, part 3.